To get started in our use or practice with contour diagrams, let's take some examples and see if we can sort them out ourselves. Let's consider three different functions, 1, 2, and 3 here. One function is the degree of pleasure you get from a cup of coffee, where the inputs are two important inputs in defining a cup of coffee, the temperature and the amount of ground coffee that can be used to brew it. Number 2, set the number of TV sets sold, so total sales, a couple of different inputs to that function that would contribute to our number of TV sets sold. One is our price for them, and Y, the other variable, could be the amount that we spend on advertising. Last but not least, our third function is going to be the amount of gas sold, so again, a sales scenario, where X is the amount we spend on gifts for our customers, wooing them back to our store, and Y is going to be the price charged by, notice here, not by us, but by a competitor. I just want to bring back some of the ideas that we saw in the last unit about increasing and decreasing. In particular here, if we take a look at the function f, if we increase x, which is our price, we expect a decrease pretty clearly in f, which is our sales. If we believe in supply and demand and price response, then our price increase will result in fewer people buying from us or fewer people buying in general, and so a decrease in the number of TV sets we sell. Contrast that with an increase in Y, which is ad spending. We certainly expect, hope, pray, let's go for expect, that if we spend more on advertising, we should sell more. Again, that's our sales that go up. If we increase our spending on advertising, we should increase our sales. So that's an important summary, really, of this relationship. The fact that f is a decreasing function of x. If I move x up a little bit, I expect f to go down, while f is an increasing function of the advertising spending. If I increase y, I increase f. Let's take that same approach and take a look at these other different functions. G, if we increase the x value, well, x here is the amount that we spend to get customers, which is basically advertising, so gifts. Then what do we expect? Well, we expect to sell more as a result. We'll get more people through the door and increase our sales. Now, if there is an increase, we can't dictate this, but if there happened to be an increase in Y, the competition's price, then we expect an increase in our sales. Let me try to contrast the G's and Y's here. Because our sales are going to increase as a result. We have a nearby competitor that's charging more customers come to us. So these two functions here have a fairly simple relationship between the inputs and the resulting output. The first one's a little more complicated, and we'll see how this plays out in the contour diagram, which we haven't forgotten about. If we talk about the temperature of a cup of coffee, an increase in X does not necessarily lead to an increase or a decrease in F. And let's be clear here, no consistent or universal increase or decrease in F. What we expect is, as the temperature goes up, we have a range where it's too cold. We don't like that lukewarm cup of coffee. We also don't like the one kind that burns our mouth, so that's too hot. There's going to be a sweet spot somewhere in the middle. The same applies for the amount of ground coffee, because it can be too strong or too weak. And too weak at this end. So a fundamentally different relationship than we see with these functions here. Now, why did I want to do all that groundwork? Well, it's going to make identifying the contour diagram that goes with each of these functions a lot more straightforward if we have these ingredients that we can fall back on. So here are three contour diagrams, and you notice two of them have a fairly similar shape to them, really. They're just lines moving off in one direction or another. This one here is definitely going to be our coffee, because this matches what we saw earlier in the unit, where we have a surface with a peak and then a decay. So there's some maximum value here where this is the temperature and this is the amount of coffee or ground coffee. And this point right here is our perfect cup. It's just lovely. Our perfect cup. Right there in the middle. Neither of these two other shapes have that idea of a maximum. There's no, oh, if I just make it a bit less strong and a bit hotter, then I reach a maximum, and if I go too far, it goes down again. Neither of those two contour diagrams imply a surface like that. So this surface goes very well with the coffee. Now, let's take a look at this one and see how it plays out. Well, as we increase x, we see changes in values, a decrease in the output. We'll take that in a second and figure out what the variable is. Also, if we increase y, going up this way, then we get an increase in the output variable. Now that example, or that shape, only matches one of the two things we looked at. It's matching increasing x leads to decreasing f, and increase to increase. So this is our TV set sold example on this graph here. Because increasing x, when we look at the contours that we would traverse as a result of increasing x, we'd be going from 300 sets sold down to 200 sets sold. If we spend more on advertising, we expect to go from 300 to 400 to 500 sold as we increase the advertising. Again, under the assumption that we're leaving the other variable constant in both of those logical steps. And that, of course, leaves us at the end here with our gas sales. So our gas sales, if we increase x, which was our gifts, well, we go from contour at height 200 to 300 to 400, so we're increasing sales. And likewise, if our competitor increases their price, that was our y value. As the competitor increases their price, our sales go up as well. So that's not how to build them yet. We're going to get to that, but it's how to interpret these contour diagrams, especially in the context of an application problem. Just to take one geometric step back, it's also worth practicing right now visualizing the surface implied by these contour diagrams. This one would be sort of a bell shape that we saw before, a nice mountain, and then again, thinking this coming out of the plane towards you, we've got lower and lower and lower levels as we move out from this peak. This surface here is low, high, higher, higher, so it's moving up in Z, or moving out towards you out of the page as we move to the northwest. This function is going up and up and up and up out of the page as we move in this direction. So it would be a sloped plane, something like that, heading as we head towards the northeast, increasing as we head towards the northeast. So again, just a good practice to visualize what these contour diagrams are telling us about the gross features of the surface that we're talking about.